All right, engineering students, let's pull back the curtain and unveil the magic behind DC generators. Ever wondered how we turn spinning motion into the electricity that powers, well, everything from your phone to your lab equipment? Let me break it down for you in the next 3 minutes. The whole secret lies in Faraday's law of electromagnetic induction. Here's the gist. When you move a conductor, like a copper wire, through a magnetic field, you create electricity. Why? Because the moving wire cuts through those invisible magnetic field lines, and boom, an electromotive force or EMF is induced right inside the wire. If you close the circuit, that EMF gets a chance to shine as a flowing current. So let's see what's actually inside a DC generator. First, you've got the armature, which is the spinning part, packed with conductors. That's your rotor. Then there are field magnets, either permanent or electromagnets, creating a powerful magnetic field. Next, the commutator, which is a clever split-ring device that flips the current direction at just the right moments. And finally, the brushes, usually made of carbon, that connect all this magic to the outside world. Here's how it all works, step by step. First, the field magnets lay down a steady magnetic field inside the generator. Then, a prime mover, think of a turbine or a big hand crank, spins the armature. As that armature rotates, its wires are constantly slicing through the magnetic field lines. Faraday's law kicks in. A voltage is induced in the wires. The formula? Induced EMF equals B times L times V times sine theta, where B is magnetic flux density, L is conductor length, V is velocity, and theta is the angle between the field and the motion. But wait, there's more. Left unchecked, the current direction would flip back and forth. Hello, alternating current. But the commutator steps in, swapping connections every half turn, and makes sure the current in your external circuit always flows one way. That's pure DC. The brushes, pressing gently on the commutator, scoop up that current and deliver it where it's needed, your load. So, let's sum it up. Field magnets create the field, armature cuts through it, EMF is induced, commutator turns AC into DC, and the brushes ferry the electricity out. And for even more control, DC generators come in types: separately excited, self-excited shunt, series, and compound varieties. Pretty cool, right? If you want to dive deeper or see some animations, just let me know in the comments.